Okay, let's look at this review problem. We have n is greater than or equal to 5. Simplify n choose 4 plus n choose 5. And before I get too far, this n greater than or equal to 5 is important because when you have a binomial coefficient, the column number has to be something greater than or equal to 0. Also, the row number has to be greater than or equal to 0. Also, the row number has to be greater than or equal to the column number. So here I need n to be greater than or equal to 5. I also need n to be greater than or equal to 4. That's redundant if n is already greater than or equal to 5. Okay, so let's start simplifying. This is equal to, by definition, n factorial over 4 factorial n minus 4 factorial. And this one is n factorial over 5 factorial times n minus 5 factorial. Okay, now I need a common denominator. Let's first deal with the easy part. This is 1 times 2 times 3 times 4. This is 1 times 2 times 3 times 4 times 5. So there's an extra 5 here that isn't here. So I'll multiply the first fraction, top and bottom, by 5. And in this way, the part that I'm underlining there would be equal to 5 factorial. In a similar way, n minus 4 is 1 more than n minus 5. So if I multiply top and bottom here by n minus 4, 5 factorial, there's the extra n minus 4, there's the original n minus 5 factorial. I'll do that so that the thing that I underline here would be equal to n minus 4 factorial. Here I have 4 factorial times 5, that's going to be 5 factorial. This factorial times the next term would be the next term factorial. So I have n factorial times 5 plus n factorial times n minus 4, whole thing over 5 factorial n minus 4 factorial, because I now rig things so that the denominators are the same. Okay, now in the numerator I can factor out the n factorial, leave me 5 plus n minus 4. Okay, now the thing in brackets is going to be n, 5 minus 4 is plus 1, so n plus 1 times n factorial over 5 factorial times n minus 4 factorial. Okay, that's correct, but I can simplify it even further. This part is 1 times 2 times 3 all the way to n, then I multiply it by an extra n plus 1. So the numerator is really n plus 1 factorial over the same denominator. And this, in turn, I can recognize as another binomial coefficient. This is actually equal to n plus 1, choose 5. Right? I have n plus 1 factorial over 5 factorial. Then if I take the difference, n plus 1 minus 5, 1 minus 5 gives me the minus 4. So my final answer is that n choose 4 plus n choose 5 somehow can actually be simplified as n plus 1 choose 5 after clearing out all of the factorials. We're not going to talk about it yet in this part of the course, but this actually is intimately connected with Pascal's triangle, and we will hit that later on this semester.